Hi, Algebra 2. We are on to lesson 4 here, and we're going to be looking at what we know about solutions to equations. Here we go. All right, we're going to start with 4.1 right here, and I want you to read this problem to yourself and try number 1 and 2. Go ahead. The 5 in this equation right here looks like it's representing the calories from other ingredients, because every carbohydrate has 4 calories, and then somehow we got to 27, we're going to have to add 5 in there. Number 2, Priya said that neither 8 nor 3 could be the solution to the equation. Explain why she is correct. That's going to involve plugging it in. So if I plug in 8 for C, so 4 times 8 plus 5, does that equal 27? No, it does not. Same thing, I could try 4 times 3 plus 5. Does that equal 27? No, it does not. So find the solution to the equation. So 4c plus 5 equals 27. I'm going to subtract 5 from both sides of my equation first, and I'm going to draw this line down with my equal sign to keep things separated, make sure I'm doing the same thing to both sides. End up with 4c equals 22. Divide both sides by 4. I'm going to end up with c equals 5.5. In number 1 here, to write our equation, we would say that Jada's earnings, E, is going to equal $12.20 per hour, however much she makes per hour, however many hours she works, minus that $7.15 for the bus fare, because that's going to end up being subtracted. Now in number 2, we know what her earnings are. This $90.45 we can put in for E, so it would be $90.45 equals 12.20 times H times the hours she works, still subtracting that bus fare. Here, if we plug in 4 to the equation, we end up with 41.65 on this right-hand side. So no, that one is not a solution because it does not make it equal to $90.45. Similarly, down here, if we plug in 7, this also does not make it equal because the right side does not equal $90.45. So to solve this in number 3, I set up my equation. I drew my line here to keep both sides of my equation separate. I added $7.15 to both sides. That's a legal move. I end up with 97.60 equals 12.20H. So I divide both sides by 12.20. So then when I divide, I end up with 8 equals 1H. So what does this solution to the equation tells us? Tell us it means that when she worked 8 hours, here's our 8 hours, that's when she made $90.45. A big difference in this problem is that the equation right here has 2 different variables in it, P for the grams of protein and F for the grams of fat. And that means when I go to test these solutions, I need to plug in a number for P and a number for F. So in A, I'm plugging in 5 for P and 2 for F. And I'm checking to see if that equals 60. So 4 times 5 is 20, plus 18. Does that equal 60? And no, it does not. So this one in A is not a solution. In B, I plugged in 10.5 for P and 2 for F, and as I'm evaluating this, I am seeing that, yes, this one does make it equal, so yes, this one is a solution. In C, I plugged in 8 for P, and I plugged in 4 for F, and as I'm evaluating this, I'm noticing that no, that one is not going to make it equal, so they're not a solution. In number 2, it's saying that if there's 6 grams of fat, so 6 in there for F, how many grams of protein are there? So I plugged in 6 for F, and I'm going to simplify what I have left. And now I have an equation that I can solve. And so I'm going to subtract 54 from both sides. And, 54 right there. And so I end up with 4P equals 6. Divide both sides by 4, and end up with P equals 1.5. So if there's 6 grams of fat, there needs to be 1.5 grams of protein. So what does a solution to this equation tell us? Well, if it's a solution, then it's a number for P and a number for F that makes the equation true. Or it's the number of grams of protein and the number of grams of fat that ends up getting us 60 calories. Okay, if you go to your lesson summary, there's a couple things that we need to draw attention to. First, it's the idea of equation in one variable. That would be like this equation right here. And that's because there would be only one variable in it. Right now, there's just one variable, W. When you have just one variable, there's only going to be one solution to that equation. Next, we saw equations with two variables. And in that case, your solution is going to be a pair of numbers that makes the equation true. So for example, down here, you have T and P, and your solutions are going to be whatever values for the number of t-shirts and whatever values for the number of pairs of socks makes the equation true, or in this case, adds up to $45.